Bismillahirrahmanirrahim. Assalamualaikum warahmatullahi wabarakatuh, and good day everybody. Welcome back to the first topic for BMMH2313 Fluid Mechanics with the topic of pressure and fluid statics. As stated before, our main textbook is Fluid Mechanics, Fundamentals and Applications by McGraw-Hill. Most of the example figure in this series of lecture is from this book. Okay, we go to the introduction. First, fluid static is the study of pressures throughout a fluid at rest, or we can call as not the fluid is not moving. As example, the fluid in the tank or in container, which the fluid didn't moving. So the fluid is in a static condition. Pressure only due to two factors. The first is the normal stress, which is the pressure, and the second is the variation of pressure is due to the weight of the fluid. Okay, we start with what is pressure. Pressure is a normal force exerted by a fluid at rest per unit area. Pressure equal to force per area, or P equal to F over A. Unit for pressure is Pascal. 1 Pascal equal to 1 Newton per meter square. Like other SI units, pressure also use normal multiplication, kilo, mega, and other multiplication. For the pressure, there is two more special multiplication. First, 1 atmosphere. One atmosphere is the natural air pressure at location just above sea level. Atmospheric pressure is equal to normally 101,325 Pascal. Okay, the other multiplication is 1 bar. Okay, 1 bar is equal to 100 Pascal. Why this bar unit become important? It is because bar is the nearest unit to room pressure, which is also as so-called as 1 atmosphere. Then with this bar unit, it is easy to imagine the pressure for engineer especially. As an example, for the situation where the pressure is 100 bar, so engineer can easily imagine the pressure is 100 times the atmospheric pressure. Value of pressure is depend on force and area. Then for the given figure, the normal stress on the feet of a chubby person is much greater than on the feet of a slim person. Why? Because the feet area for both person is same. Then high pressure will definitely give high pressure. For a situation where pressure is due to static fluid, pressure is a normal force exerted by a fluid at rest per unit area. There is two types of pressure, absolute pressure and also gauge pressure. Absolute pressure is the actual pressure at a given position. For absolute pressure, it is measured relative to the absolute vacuum. So we can see in the equation, P absolute is equal to P atmosphere plus OGH, or OGH is also the gauge pressure for the given position. Then for gauge pressure is the different pressure between the absolute pressure and the local atmospheric pressure. Most pressure measuring device are calibrated to read zero at the atmosphere. So that's why P gauge is important in this class. This figure shows the relationship between P absolute, P atmosphere, and also P gauge. So for the line at the bottom, it is the absolute vacuum line, where P absolute on the location is 0. And then the line at the center is the P atmosphere, or the normal pressure we feel in the room pressure. So as discussed before, P gauge is the difference between the absolute pressure and local atmospheric pressure at any point, and the one that we normally measure using any gauge. So if we want to measure the P absolute, we need to add P atmosphere to the P gauge. And then it same goes in case the gauge show the pressure in vacuum condition. So in this case, to get the P absolute at the location is P atmosphere minus P vacuum. If P gauge is the pressure above the P atmosphere, while P vacuum is the pressure below P atmosphere. So which one in the between these two figures is vacuum pressure and which one is gauge pressure? Okay, we look at the system A. In the system A, we can see that the level of water at the is lower than the side that toward the system. So this indicate that the pressure is in vacuum, because low pressure at the system A will give a suction effect, which in result the liquid enter the space of the system. While for system B, we can see that the level of the water toward the system is lower than the other one. So for this one is when the pressure at system B is higher than the atmosphere, it will give the push effect to the liquid. So this why the situation in the figure occur. Let's try several example. Okay, we start with example 1. A vacuum gauge connect to a chamber reads 5.8 psi at a location where the atmospheric pressure is 14.5 psi. Determine the absolute pressure in the chamber. Okay, we got that P gauge is equal 5.8 psi and P atmosphere is 14.5 psi. We already know the relation between P absolute, P atmosphere, P gauge and P vacuum. P absolute is equal P ATM plus P gauge, while in case for P vacuum, P absolute is equal to P atmosphere minus P vacuum. So for this case, the given is the P atmosphere and also P vacuum. Then we need to do is the numbers 14.5 psi as P atmosphere minus 5.8 for P vacuum, and then we got the answer is 8.7 psi. Okay, we go to the second example. Express a pressure of 155 kilopascal gauge as an absolute pressure. Okay, where the local atmospheric pressure is 101 kilopascal. Okay, we got the P gauge equal to 155 and P atmosphere equal to 101. So to get the P absolute is P gauge plus P ATM. Hence, the answer is 155 plus 101 equal to 256. Okay, the next one is express a pressure of negative 31 kilopascal as an absolute pressure. So we use the same equation. P absolute equal to P gauge plus P ATM. P gauge equal to negative 31. P ATM equal to 101. Negative 31 at 101 equal to 70 kilopascal. Okay, example 3. Express a pressure of 155 kilopascal gauge as an absolute pressure. Okay, it is the same method for solution. The local atmospheric pressure at the location is 98 kilopascal. So same like how we solved before. P absolute equal to P ATM plus P gauge. P ATM 98, P gauge is 155. So we got it is equal to 253 kilopascal. Okay, next example. express a pressure of 225 kilopascal absolute SN gauge pressure. The local atmospheric pressure at the location is 101 kilopascal. Okay, so P absolute equal to P ATM plus P gauge. So P gauge equal to P absolute minus P ATM. So P gauge is 220. P absolute is 225, and P atmosphere is 101. 225 minus 101 equal to 124 kilopascal. Okay, the last example, express a pressure of 75.2 kilopascal as a gauge or vacuum pressure. The local atmospheric pressure is 103.4 kilopascal. Okay, we got the P absolute equal to 75.2 kilopascal, and the local atmospheric pressure PATM is 103.4 kilopascal. So we got that P gauge equal to P gauge equal to P absolute minus P atmospheric. So we got the answer is 175.2 minus 103.4 equal to negative 28.2 kilopascal. So if we use the P gauge, then the answer will be negative 28.2 kilopascal. But if we use a P vacuum, the answer will be 28.2 kilopascal without the negative sign. Okay, see you again in the next slide.